So long back roan is preferred in morning because it is easier to get longitude at noon with correction, no needs of plotting, accuracy of fix is increased with PL. Observed with long back roan, the angle of cut is as close to 90 degree. In morning the altitude is changing quite fast as compared to the azimuth, and in the formula of intercept this fast change of altitude can cause error in calculation of TZD and hence error in the intercept, whereas in the long background true altitude is in numerator, so small error does not affect the accuracy of a fix. Now we have to look for how we have to calculate it. Like from the formula we will be getting the long background P, determining P, and then after determining P we will get the azimuth, then from it we get the P position line, from that DR long. Okay, now a common method to obtain the noon position of ship at sea is to transfer the position line obtained from a sun site in the morning up to the time of the sun's meridian passage. At that time the latitude of the ship is obtained from meridian altitude of the sun. This position line will run east west. Okay, this position line will run east west because our latitude is only our PL. Now the position of the ship at the time of ship's meridian passage, that is apparent noon, is where the transferred PL intersect the altitude latitude obtained by meridian altitude is not the ship's position at 1200 hours by the ship's clock. The above method would give the true position of a ship at apparent noon only if the run allowed between the sites is the exact and distance made good by the ships during the interval between the site. If the DR latitude used for the working the morning site was correct, if the DR latitude used for working the morning site was correct, the longitude obtained then would be correct, and therefore the longitude at apparent noon calculated by applying this run to the morning position would also be correct longitude of the ship then. Okay, what is the intercept method? Now this is where we take a difference between MZD and TZD, and that is become the intercept, and from that we get a PL. In intercept method, the DR latitude and longitude of the vessel at the time of sight are used in the calculation. Using the formula, the angular distance from the geographical position of celestial body to the DR position is calculated. This is called the calculated zenith distance. This is compared with the true zenith distance, which is obtained with the sextant. Okay, the distance between CZD and TZD is called the intercept, which is expressed in minutes or arc. Obtaining the intercept from the celestial observation involves observing the sextant altitude and GMT at that instant, obtaining the GHA and declination of that body for that time, determining the R angle of the body using GHA and DR longitude, calculating CZD using the formula, obtaining the TZD from the sextant altitude, comparing the TZD and CZD to obtain the intercept, which will be named away if TZD is greater and toward if TZD is lesser, obtaining the azimuth and from it the direction of PL. Now what is the difference between long back roan and intercept method? One of the key differences between the two sites, that is long back roan and intercept sign wing, in the PL of former one point on the PL is known, whereas in the case of later the point on PL is not known. Long back roan involves a known initial position, while intercept site means involve finding the position through a process of adjustment and intersections of lines of position. Why long back roan is preferred for morning site, whereas intercept method is used for evening site. Long back roan morning site is a long back roan method often involve taking a site at noon when the sun is at highest point in the sky. This involves a clear and easily identifiable reference point, making a convenient time for navigation observation. No sites are considered accurate for determining longitude because the sun's position is relatively easy to measure precisely when it is at its zenith. Intercept method, celestial bodies such as stars and planets become more visible as the sky darkens in the evening. The intercept method often involves taking sights on these celestial bodies. Evening sight may involve multiple celestial bodies, providing the navigator with more reference point to create intersecting line of position. The intercept method is often used to obtain a fix, determining the ship's position by intersecting lines from multiple celestial bodies. This can be especially useful during the evening when there are more visible stars. In some words, for intercept, you need more than one body to obtain fix because you need at least two position line to intersect. At least three should be taken to get an accurate fix, and in morning you only need sky and sun. What is deviation and variation? Deviation is the angle between the magnetic meridian and the north-south line of the compass card. Deviation is termed easterly if the compass north lies to the east or right to the magnetic north, and westerly if the compass north lies to the west or left of the magnetic north. The deviation of a compass varies as the ship's head changes. Variation is the difference between the true north and the magnetic north. The variation for your local area is found by looking at the compass rose on your chart. The variation for your local area is found by looking at okay. Now what is the working, explain the working of sextant and its measurement for sextant, altitude of the celestial body, VSA and HSA. Okay, principle of sextant: when a ray's light undergoes reflection by two mirrors inclined in the same plane, the angle between the original incident and in the final emergent ray is twice the angle between the mirrors. Errors of sextant: centering error, pivot of the index bar not situated at the geometric center of the arc. This error is rarely present, it is caused by careless handling. And shade error, refraction through consecutive shades. Error of collimation, the axis of telescope not parallel to the plane of the sextant. Error that can be corrected on board the ship. Error of perpendicularity, the index bar not perpendicular to the plane of the sextant. Now how to correct it? Just clamp the index bar about halfway along the arc. Now hold the sextant horizontally with the arc on the further side and look obliquely into the index bar. The arc and its reflection in the interval should appear to be in the one straight line. If not, error of perpendicular exists. Cure: carefully alter the setting of the first adjustment screw situated at the top of the frame of index mirror. Now what is side error? The horizontal glass not perpendicular to the plane of the sextant. Now how to check it? Just clamp it to 0 degree, hold the sextant vertically and look at heavenly body. Turn the micrometer one way and then the other while looking at the body. The reflected image of the body will move above and below the direct image and should pass exactly over it. If the reflected image passes to the left or right of the direct image, side error exists. Cure: carefully alter the setting of the second adjustment screw situated at the top center of the frame of the horizon glass. Carefully alter the setting of the second adjustment screw situated at the top center of the frame of the horizon glass. Side error: the horizon glass not perpendicular to the plane of the sextant. How to check? Clamp the index at 0 degree, hold the sextant vertically and look at the heavenly body. Turn the micrometer one way and then the other while looking at the body. The reflected image of the body will move towards the below the direct image and should pass exactly over it. If the reflected image passes to the left or right of the image, side error. वापस से the horizon glass not perpendicular to the plane of the sextant. This is so bring it to 0, hold the sextant vertically, look at the heavenly body, turn the micrometer one way and then other while looking at the body. That reflected image of the body will move above and below the direct image and should pass exactly over it. If the reflected image passes to the left or right of the direct image, side error exists. Carefully alter the setting of the second adjustment screw situated at the top center of the frame of the horizon glass. Now index error. Index error and the horizon glass not exactly parallel to each other when the index is set to 0. Index error is the difference between the optical 0 of the sextant and its graduated 0. Index error is termed off the arc if the optical lies to the right of the graduated 0. Index error is termed on if the optical lies to the left of the graduated 0. Index error is termed on the arc if the optical zero lies to the left of the graduated zero. Left of the graduated zero. How to check? Clamp the index at 0 degree. Hold the sextant vertical at the horizon. How to check it? Clamp index at 0, holding the look at the horizon. The reflected image in the silvered half of the horizon glass and the direct image in the reflected image in the silvered part of the horizon glass and the direct image in the unsilvered part of the horizon should appear in a perfect line. If not, turn the micrometer until they coincide exactly. The reading of the micro on of the arc, as in the case, it gives an index error. Okay. Cure carefully alter the setting of third adjustment situated at the base corner of the horizon glass. Describe the correction to sextant altitude. We will take index error. Now the other is dip, our position. Now note, correction of altitude may be taken from nautical table or from the nautical unit. Dip is tabulated against. Okay, the apparent altitude is obtained for celestial for the sun. The total is given two columns, one for October to March and I want study. Following description of correction applied. True altitude of a heavenly body is the arc of the vertical circle or the angle at the center of the earth contained between the plane of the observer's rational horizon and the center of the body. To obtain the true altitude of the body, various correction have to be applied to its altitude measured by the sextant. The correction in order to they are we have to follow index, dip, error, refractions and parallax of a heavenly body is the arc of a vertical circle or the angle at the center of the earth contained between the plane of the observer's rational horizon and center of the body. True altitude of a body is the arc of vertical circle or the angle at the center of the earth contained between the plane of the observer's rational horizon and center of the body. Correction have to be applied to its altitude measured by the sextant. The correction is the order they are to be applied. Follow index error, refraction, semi-diameter and index error is the instrument error of the sextant used in measuring the altitude. The sextant altitude is therefore corrected first for index error, that is added if it is off the arc and subtracted if it is on the arc. Dip is the angle at the observers between the plane of the observer's sensible horizon and the direction of the visible horizon. Dip occurs because the observer is not situated at sea level. The value of dip increases as the observer height of height increases. Okay. Now apparent altitude is the sextant altitude corrected for index error and the dip. Refraction is the deviation of the light rays passes from the one medium to another when passing from a rarer medium to into a denser. Then the ray deflects towards the normal to the surface of the separation between the two media. Since refraction increases, the apparent altitude of the refraction correction is always negative. Since refraction increases, the apparent altitude of the body refraction correction is also negative. In the almanac, they tabulated under the head total correction for stars and planets. Besides index error and deep refraction, in the one only correction necessary for star altitudes. So refraction correction is always negative. Refraction correction is always negative. Passing from a rarer medium into denser medium, they reflect towards the normal to the surface of the separation between the two media. Since the refractions increases the apparent altitude of the body, refraction correction is always negative. Apparent altitude of the body. This increases the apparent altitude of, okay, in Almanac tablet beside the index error and okay. Semi-diameter. The values of declination GH of various celestial bodies tabulated in Almanac are those their center. Since their parameter used in working a site refer to the center of the body, it is essential that the body's zenith distance used in the working and therefore the true altitude should also refer to the center of the body. The sun and moon present visible disk to the observer. It is not possible to measure the altitude of their center as it is difficult to judge their exact center by sight. Therefore, we measure the altitude of either their upper limb or lower limb, to which we apply half the apparent diameter of the body to obtain the altitude of the center. We apply half the apparent diameter of the body to obtain the altitude of their sun. Okay, it is obvious that the semi diameter should be added to an altitude of the lower limb and subtracted for the altitude of upper limb center of the body. The semi diameter of sun is tabulated once for every 3 days in the semi diameter of the sun is tabulated once for every 3 days in daily pages of the nautical almanac for the moon. It is tabulated for each day. Parallax, horizontal parallax of the body is the angle at the center of the body contained between the center of the earth and the observer at the surface of the earth and the body is on the observer's sensible horizon. Parallax in altitude is the angle at the center of the body contained between the center of the earth and the observers on the surface of the earth when body is at any altitude. It may be observed that parallax is maximum when the body is on the sensible horizon, and it is reduced as the altitude increases till it becomes nil when the body is at the observer's zenith. It is observed that the parallax of body will reduce as the distance from earth increases. Parallax correction is therefore always additive. Parallax correction is therefore always additive. Parallax correction is for the sun is always the various nautical table. It is tabulated as the substance of the altitude. It varies from 0.15 minute when the altitude is nil to 0 when sun is at the zenith. For planets, the correction combined with the correction for phase is given as an additional correction when the under the head stars and planets on the cover page of the nautical almanac. For the moon, the horizontal parallax is tabulated for each hour. Its value is around 60 minute. Total correction in practical navigation corrections such as a refraction correction for parallax and phase and parallax in altitude are given as total correction. Total correction tables for various celestial bodies are available on the front and back cover pages of the nautical almanac and in the nautical tables. After applying the index error, if any, the dip correction is subtracted to obtain the apparent altitude. The apparent altitude is used as the argument to obtain the total correction for the various bodies. Total correction in practical navigation are corrections such as refraction correction for parallax and phase and parallax in altitudes are given as total correction. Total correction tables for various celestial bodies are available on the front and back cover pages of the nautical almanac and in the nautical tables. After applying the index error, if any, the dip correction is subtracted to obtain the apparent altitude. The apparent altitude is used as the argument to obtain the total correction for the various bodies. Total correction tables for various celestial bodies are available on the front and back cover pages of the nautical almanac and in nautical tables. After applying the index error, if any dip correction is subtracted to obtain the apparent altitude, the apparent altitude is used as an argument to obtain the total correction for various bodies. Tables of total correction are provided separately for stars and planets, for the sun and for the moon. The total correction for stars consists of the refraction correction alone. Further small correction is provided for Venus and Mars due to their proximity to the Earth to allow further parallax and phase. Further small correction is provided for Venus and Mars due to their proximity to the Earth to allow further parallax and phase. Total correction table for Sun is provided separately for lower limb and upper limb observation for 2 periods of the year. The total correction table for Moon is provided in 2 parts. In the upper part, the correction are tabulated as a function of the apparent altitude. The correction is additive to the lower limb observation. In the case of upper limb observation, also correction to be added but 30 degree to be subtracted thereafter. The lower table gives the correction for parallax separately for lower limb and upper limb as a function of the horizontal parallax obtained from the daily pages. This correction is also additive. When and how to take amplitude of the sun. Amplitude must be taken when the body center is on rational horizon, which means the sun's amplitude must be taken when sun's lower limb is half the semi-diameter above the visible horizon. Amplitude must be taken from the bodies when the rational horizon is half diameter. Okay, take a visible horizon on. Okay, now we are taking an example. We are in the DR position and this is our date, and we know that like variation in axis we get the variation. We just from the compass bear we just took the bearing 100 degree. Okay, now From deviation card we will get the deviation as well. Now looking at this, we will be getting our GMT time. Okay, look in the rows indicating sunrise against latitude. There are different rows, north and south hemisphere. Note the required latitude between the tabulated values of these and interpolate for sunrise for LMT of sunrise to the nearest whole number of the time. In this case, this okay, this is the LMT time. Tabulate the values as shown and calculate the GMT of the sunrise. We get the GMT. Okay, after getting the GMT, we'll be getting declination and latitude. We know, right? Calculating the declination for the calculated GMT and directly verify sign declination by cos plot. We get the cos amplitude, and then azimuth we just take as southeast. For if it is morning, it is east, and if it is after 12 o'clock, it is west, and if setting, it is west. Sorry. And the declination sign, we use the name of the declination and we get the tabulated various form of the deviation of the card. Now this is just an example. True azimuth is 97.2, we are getting. Compass azimuth is 100. So if we see, error is 2.8 degree, sorry, variation is 3 degree and deviation is 5.8. so we come to know true to compass, then it is the okay. So here we get is 2.8. okay. Now what is back angle? When the near horizon is not available for sight due to fog or intervening line, it is impossible to measure. It is possible to measure to the altitude of the celestial body to opposite point of the horizon. The altitude thus measured to the far horizon will be over 90 degree and it is called as a back angle. Such an observation is possible only when body is fairly close to the observer zenith as a sextant altitude measured angle greater than 120. To correct a back angle observation, index error, deep and SD are applied initially. The angle so applied is subtracted from 180 degree and refraction parallax also obtained then applied to it. All corrections are applied with normal sign as for an observation to the near horizon. What is back angle? Is the horizon not available for sight due to fog or intervening? It is possible to measure the altitude of a celestial body to the horizon. The altitude thus measured to the far horizon. The far horizon will be over 90 and is called as a back angle. Such an observation is possible only when the body is fairly close to the observation. This we have to discuss. Now, does the long background intercept have the same line of position? No. Long background method and intercept method in celestial navigation do not typically result in same position line. The long background method involves calculating the ship's longitude based on observed local solar time, resulting in a meridian line on the chart known as the LOP. In contrast, the intercept method involves taking sight on celestial body, creating LOP based on the assumed position and determining ship's position at the intersection of these lines. While both methods provide information about the ship's location, the LOP from the long back road method and intersecting LOPs from the intercept method generally represent different position on the chart. At what time and altitude we take of the sun in the morning? The local time for the site is close to 0900 ST. Sun must reach an altitude of at least 15 degrees so that the refraction correction is low. Though for the altitude smaller than 15 degree, refraction correction are not available, but if the actual refraction correction is even out by 2 to 3 minutes, the accuracy will be affected reasonably, whereas if the refraction correction itself is low, then the chances of errors will be low too. The local time for the site is close to 0900. Sun must reach an altitude of at least 15 degrees so that the refraction correction is low. Refraction correction is low, though for the altitude smaller than 15 degree refraction are not available, but if the actual refraction correction is even out by 2 to 3 minutes, the accuracy will be affected reasonably, whereas if the refraction correction itself is low, then chances of error will be low too. Define the respect to the equinoctial system. Declination. Declination of a celestial body is the arc of celestial meridian or the angle at the center of the earth contained between the equinoctial and the parallel of the declination through the body. Declinations are measured from 0 to 9 degree or north or south of the equinoctial. Sidal R angle is the arc of the equinoctial or the angle at the celestial pole contained between the celestial meridian of the first point of Aries and through the body, measured westward from the Aries. Right ascension is the arc of equinoctial or angle at the celestial pole contained between the celestial meridian of the first point of Aries and the body measured eastward from the Aries. Greenwich R angle of the body is the arc of equinoctial at the celestial pole contained between the celestial meridian of the Greenwich and that of the measured westward from the Greenwich. LHA of a body is the arc of equinox of the angle at the celestial contained between the observer's celestial meridian and the celestial meridian of the body, measured westward from the observers. Okay. Now, rational horizon. The observer's rational horizon is a great circle on the celestial sphere where every point on which is 90 degree away from its zenith. Now, true altitude of a body is the arc of the vertical circle through that body contained between the rational horizon and the center of the body. True altitude of a body is the arc of the vertical circle through that body contained between the rational horizon and the center of the body. Zenith distance of a body is the arc of the vertical circle through zenith distance of a body is the arc of the vertical circle through the body contained between the observer zenith and the center of body. Zenith distance of a body is the arc of the vertical circle through the body contained between the observer's zenith and the center of body. The body is the arc of the vertical circle of a body is the arc of the vertical circle through the body contained between the observer's zenith and the center of the body. Of a body is the arc of the vertical circle is the arc of the vertical circle through the body contained between the observer's zenith and the center of body. Of a body is the arc of the vertical circle through the body contained between the observer's zenith and the center of body. Of a body is the arc of the vertical circle through the body contained between the observer's zenith and the center of body. For zenith of a body is the arc of the vertical circle through the body contained between the observer's zenith and the center of the body. The azimuth. The azimuth of a celestial body is the arc of the observer rational horizon or the angle at the zenith contained between the observer's celestial meridian and vertical circle through the body. The azimuth of a celestial body is the arc of the observer's rational horizon or the angle at the zenith contained between the observer's celestial meridian and the vertical circle through that body. The azimuth of a celestial is the arc of the observer's rational horizon or the angle at his zenith contained between the observer's celestial meridian and the vertical circle through that body. The azimuth of a celestial body is the arc of the observer's rational horizon or the angle at his zenith contained between the observer's celestial meridian and the vertical circle through the body. The azimuth of a celestial body is the arc of the observer's rational horizon or the angle at his zenith contained between the observer's celestial meridian at the vertical circle through that body. The azimuth of a celestial body is the arc of the observer's rational horizon or the angle at a zenith contained between the observer's celestial meridian and the vertical circle through that body. Vertical circle word use करना है, ठीक है. Amplitude also somewhat like the same prime vertical word use करना है between the observer's prime vertical and the vertical circle of the body when the body is on the observer's rational horizon or at the theoretical rising or setting. Now, what is geographical position of a body of a celestial body is the point on the surface of the earth vertically beneath the body and the body at which a straight line from center of earth to the celestial body meets the earth's surface. Condition of a twilight all night. Condition for twilight all night. For continuous twilight throughout the night, the observer's latitude and sun's declination should be of the same name and the limiting latitude are obtained as latitude plus declination is less than 90 degree plus minus 90 degree, and latitude plus declination plus minus 18 degree is more than 90 degree, so that the sun will set, so that the sun will not go below that violet belt. Okay, so we have the same name, sun's declination. For continuous twilight throughout the night, the observer's latitude and sun's declination should be of same name. Observer's latitude and sun's declination should be of same name. Condition for solar eclipse. A solar eclipse happens when moon comes in between the sun and earth. What is the pivot point? Pivot is an imaginary point of the vessel about a vessel's turns position. Speed changes with respect to the motions of the vessel. The pivot point is significant because it allows the ship's operator to predict how vessel will have behave during a turning. The pivot point is used in navigational planning to determine space needed to a vessel to execute turn safety. Since pivot point changes with respect to the movement of the vessel, pivot point can be explained with the following situation: vessel stopped is it is at the same point as the longitudinal center of the gravity, or the vessel is stopped and making no movement and making headway. Forward momentum, longitudinal resistance to forward created by water ahead of these two forces will strike a balance, and the pivot point moves forward. As a rough guide, the 25 assume 25% of the ship's forward momentum at a constant speed is spent in overcoming the longitudinal resistance, and the pivot point will be approximately 1 by third length or 1 by fourth from the forward, making sternway same the 1 by fourth from the stern. Now what is the turning circle of a ship's, what is it significant? A ship's turning circle is the path followed by the ship's pivot point when making a 360-degree turn. A ship's turning circle is the path followed by the ship's pivot point when making a 360-degree turn. The knowledge of the turning circle is vital to a navigator, as this measure gives an idea of the whether there is a sufficient sea room is case needed to be taken during an emergency. What is advance? Advance is the distance traveled by a center of gravity along the original course line in the forward area until there is a 90-degree change from the original course. Advance is a crucial factor for ship's operator when planning turns, especially in confined waters such as the ports, narrow channels, or during the navigation through busy traffic. Calculating advance is part of assessing the ship's turning characteristic, which is vital for navigation safety. It aids in determining the minimum turning radius required and helps the prevent a collision with other vessels, structure, or navigational hazard. Now what is transfer? Transfer is the distance traveled at right angle by the transfer is the transfer it is the distance traveled at right angle by the ship's center of gravity from the original coastline to the point where the course has changed by 90 degree. It is the distance traveled at right angle by the ship's center of gravity from the original coastline to the point where course has changed by 90 degree, or the distance a vessel move horizontally at a point in turn measured 90 degree from the original course. What is the tactical diameter? Is the perpendicular distance between a ship's course when the helm is put hard over and its course when ship has turned through 160 degree. Tactical diameter is the perpendicular distance measured between a ship's course when the helm is put hard over and its course when she has turned through 180 degree. The distance measured from the original course to the point where the vessel is 180 degree from its original heading. IMO requires the maximum tactical diameter is 5 times of the ship's length. 5 times of the ship's length. Tactical diameter, it is the perpendicular distance between the ship's course when the helm is put hard over and its course when the ship has turned to 180 degree. It is the perpendicular distance between the ship course when helm is put hard over and its course when she has turned 180 degree. It is the perpendicular distance between a ship course when the helm is put hard over. It is a perpendicular distance from the course when the helm is put hard over and its course when the she has turned through 180 to the course and its course when she has turned through 180 degrees, the distance measured from the original course to the point where the vessel is 180 from is the original heading. IMO require the maximum technical diameter is 5 times the ship's length. Now drift angle. Drift angle is the angle between the ship's fore and aft line and tangent to the turning circle at any instant. Drift angles give the correct idea of inward inclination of ships with respect to tangent. It is the angle between the ship's fore and aft line and tangent to the turning circle at any instant. Drift angle gives the correct idea of inward inclination of ship with respect to tangent. The drift angle provides information about how much the ship's actual course deviates from its intended or desired course. Drift angle is the angle between the ship's fore and aft line and the tangent to the turning circle at any instant. Drift angle gives the correct idea of inward inclination of ship with respect to tangent. Drift angle is the angle between the ship's fore and aft line and the tangent to the turning circle at any instant. Drift angle gives the correct idea of inward inclination of ship with respect to tangent. Correct idea of inward inclination of ship with respect to tangent. The drift angle provides the information about how much the ship's actual course deviates from its intended or desired course. It helps the ship's operator make necessary steering adjustment to maintain the desired heading. Head reach. It is defined as the distance along the direction of the course at the moment when full astern command was given. Head reach. It is defined as the distance along the direction of the course. Distance along the direction of the course at the moment when full astern command was given. The distance is measured from the moment when full astern command is given until the vessel is stopped dead in the water. It is defined as the distance along the direction of the course at the moment when full astern command was given. The distance is measured from the moment when full astern command is given until the vessel is stopped dead in the water. Track reach. It is defined as the distance along the vessel's track that vessels covers from the moment that the full astern command is given until head speed changes. It's a measures of the distance traveled during the deceleration phase of the crest stop maneuver. The stopping ability of the vessels is judged 5 times क्या था tactical diameter. Okay. Now track reach is 15 times the ship's length. The stopping ability of the vessel is done using a full astern crest stop maneuver based on IMO requirements. The track reach should generally not exceed 15 times the ship's length. Now why do we need a head reach and track reach? Stopping distance is the distance which a ship will continue to move after action is taken to stop engines until the ship comes to rest. Stopping distance details may be provided for sea speed, harbor speed, half speed, etc. It may be provided for loaded and a light condition. It may be provided for loaded and light conditions. Stopping distance is the distance which a ship will continue to move after action is taken to stop engine and still the ship comes to rest. Stopping distance details may be provided for sea speed, harbor speed, half speed, etc. It may be provided for loaded and light conditions. Stopping ability is measured by the track reach and a head reach realized in a stop engine full astern maneuver performed after a steady approach at the test speed until head speed in ship's coordinate changes the sign. Why do we need a head reach and a track reach? Stopping distance is the distance which a ship will continue to move. Stopping distance is the distance which a ship will continue to move after action is taken to stop engines until the ship comes to a rest. Stopping distance details may be provided for sea speed, harbor speed, half speed, that is, it may be provided for loaded and light conditions. Stopping distance is the distance which a ship will continue to move after action is taken to stop engine until the ship continues to rest. Stopping distance details may be provided for sea speed, harbor speed and half speed, etc. It may be provided for loaded and light conditions. Stopping distance is the Why do we need head reach and track reach? Stopping distance is the distance which a ship will continue to move after action is taken to stop engine until the ship comes to a rest. Stopping distance details may be provided for sea speed, harbor speed, half speed, etc. It may be provided for load and light conditions. Stopping ability is measured by track reach and head reach realized in stop engine astern full astern maneuver performed after a steady approach at the rest test speed until the ahead speed in ship coordinates changes the sign. What are types of stopping distance? Inertia. When the engine of the ship is stopped, the ship will continue to move in the same direction for some more distance due to the inertia. Here, no astern command is given, and hence ship will travel more distance in the inertia stop method. Crash stop is usually the term used when the ship has to sudden stop in emergency. Here, the engine, which is moving in an ahead direction, is giving an order to full astern or leaving the rudder in the mid position to stop the ship within a minimum distance and the shortest possible time. Crash stop is usually the term used when the ship has to sudden stop in emergency. Here the engine which is moving in an ahead direction is given an order of for full astern, leaving the rudder in the midship position to stop the ship with minimum distance and shortest possible. This is crash stop. Or see, okay. Now the ship will continue to move in the first astern command is given, and once here and no astern command is given, the ship is stopped. The engine will come when the engine of the ship is stopped. The engine will continue to move in the same direction for some more distance due to the inertia. No astern command is given, and hence ship will travel more distance. Inertia stopped. Okay, head reach, track reach. Okay. Now ship to ship now different kind of interaction, ship to ship interactions. With ship to ship will be on another courses, and okay. Now bow to bow. It will repel each other. Consider two vessels on a close approach. Now combination positive bow pressure zones encourages to be repelled and excessive. Okay. Now two ships abeam. So in this, when abeam, the combined low pressure zones encourage a suction. If the vessel are very close, can cause a violent broadside collision. Broadside collision. The bow of each vessel now comes under the influence of the other vessel's astern, which also means the rudder of each vessel is being affected by the positive pressure of the vessel's bow. This causes each vessel to take a sheer towards the other vessel, and if in narrow channel or fairway, for stern to be cast towards the boundaries of the channel or fairway. Now stern to stern. As each vessel draw clear, the combined lower pressure causes the stern to be withdrawn towards each other and assist the vessel to regain their cause the sterns to be drawn and towards each other and assist the vessels to regain the original track. Okay, original track पे जाएंगे. Bow to stern interaction. A vessel A approaches vessel B. The pressure domain of bow of A intersects with the stem of B and pushes her stern away, causing B to shear across the path of A, which is the overtaking vessel. Additionally, A will sense the low pressure of B and it may display heightened tendency to swing towards B. Ship B may experience a push forward and hence increase in speed due to the pressure domain of A. Now, two ships abeam will experience powerful pressure zone at the bow and low pressure abaft. The respective pivot point, bow will swing out and stern sucked in. Initiate corrective action will in the time should the two vessels be allowed to close. The smaller of the two will get dragged with the bigger. Now stern to bow interaction. Stern to bow interaction. The overtaking vessel passes ahead of the overtaken may sense the effect of its bow being sucked towards vessel A and bank effect. Okay. What are the factors affecting the turning circle of the ship? Structural design and the length of the vessel. Generally speaking, the longer the ship, the greater the turning circle. Smaller the clearance between the rudder and the hull, the more effective will be its turning action. Draft and trim. The deeper a vessel lies in the water, the more sluggish will be her response to her helm. Ships usually trim by stern for ease of handling in purpose, but it should be noted that if the vessel was trimmed by the head during the turn, the circle would be indistinctly reduced. Now, what is motive power? The turning circle will not be increased by a great margin with an increase in speed because the steering effect is increased over the same common period. The steering period is increased over the same common period. Now, what is the distribution and storage? Because of the distribution and storage of the car, if cargo is on board on the vessel, it will respond more favorably if the loads are is in amidship position as opposite to the extremities of the vessel. Where loads are at the ends of the vessel, at maneuver will be sluggish. When the loads are at the ends of the vessel, any maneuver will be sluggish and slow in response to helm action. Available depth of water. Shallow could affect the response time and cause the circle would be tight, but it will be accompanied by considerable loss of speed. Why turning circle are larger in shallow water? The limited water depth shallow water will change the pressure distribution around the vessel and lead to an increase in hydrodynamic forces. The maneuverability decreases, which amongst the other things manifest itself in a substantial increase in the turning circle of the vessel or the required bend radius. What is a transverse thrust? Transverse thrust is a hydrodynamic force generated by a propeller on a ship that acts in a direction perpendicular to the ship's longitudinal axis. The initial the limited water depth shallow water will change the pressures distribution around the vessels and lead to an increase in hydrodynamic forces. The maneuverability decreases, which among other things manifests itself in a substantial increase in the turning circle of the vessel or the required bend radius. Available depth of the radar angle. Where the radar angle is employed, the turning circle will be tighter, but it will be accompanied by the considerable loss of the speed. The limited water depth shallow water will change the pressure distribution around the vessel and lead to an increase in the hydrodynamic forces. The maneuverability decreases, which among other things manifests itself in a substantial increase in turning circle of the vessel or other required bends or other bend radius. What is transverse? Transverse is the hydrodynamic force generated by a propeller on a ship that acts in a direction perpendicular to the ship's longitudinal axis, which acts perpendicular to the ship's longitudinal axis. When a propeller rotates, it produces swirling flow of water behind it, creating a pressure difference between the sides of the propeller. The effects of transverse thrust when going ahead are so minimal they can generally be ignored, but when operating astern propulsion, the water flow expels water in the forward direction. The water flow expels water in the forward direction. Then this in turn is deflected by the hull form, causing a sideways push on the hull. Transverse thrust for a right-handed propeller is tendency to give a small push to a starboard of the stern part of the vessel when running ahead. Transverse thrust for a right-handed propeller is tendency to give a small propeller to a starboard of the stern part of the vessel when running ahead. On a stern propulsion, it is opposite of that. Now what is a bank cushion effect? Where a vessel is brought into a close proximity of bank, as it is in a channel or river, it may experience a pressure build up between the hull and the obstructing bank, known as bank cushion effect. When the ship is near to the bank, the water is then forced between the narrowing gap between the ship's bow and the bank. The water tends to pile up on the starboard side of the ship, causing ships to shear away from the bank. This pressure buildup will effectively turn the bow of the vessel away from the bank and force the ship's heading into the middle channel area, away from the restriction of the channel sides. A form of interaction often experienced in shallow water areas like rivers and channel where the vessel is observed to experience what is called and experience a bodily sinkage and sit lower in the water than would normally happen. As in deep water, a vessel may squat by the head or by the stern, but is more often a common occurrence to a squat by the stern. Squat is directly related to the speed square of the wave. Factors affecting squat: draft, depth of water, ratio, highly ratio of equates to a greater rate of squat. The position of the longitude center of buoyancy will determine the trimming effect and have a direct relation to the squat value. The speed of the vessel is related to the value of squat, in that value is influenced by speed square. The faster the ships move to the greater the squat value. The length breadth ratio can cause an increase or decrease of the squat value. That is, the short tubby ships tends to squat more than the longer narrow beam vessel with a large buoy coefficient will experience a greater effect from squat. A greater effect of squat are experienced when a vessel is trimmed by the bow than by the stem. How to know the ship is experiencing a squat effect? The indication that a vessel is experiencing squat will show from the steering being affected. Waves from the ship's movement will probably increase in amplitude and the wake left by the vessel will probably must stand. Some vibration may also occur with the decrease in speed and a reduced RPM. Why does squat effect happens? What is the formula for squat? The squat effect is the hydrodynamic phenomena by which a vessel moving through the shallow water creates an area of reduced pressure that causes the ship to increase its draft and thereby closer to the seabed than would otherwise be expected. Now, when a ship squat, it means that a ship turns and move are pushed down into the water as it moves forward. This phenomena is caused by the hydrodynamic forces acting on the ship as it moves through the water. As the ship gains speed, the water flow around the hull creates a low pressure area beneath the ship, causing it to squat. This can lead to reduction in UKC, which is distance between the ship's keel and the seabed. Squat can be influenced by factors such as the ship's speed, shape and displacement, as well as the depth of the water. Pilots and ship's captain need to be aware of the squat when navigating in restricted or shallow waters to ensure a safe passage. When a ship squat, it means that the ship's stern and bow are pushed down into the water as it moves forward. This phenomena is caused by the hydrodynamic forces acting on the ship as it moves through the water. As the ship gains speed, the water flow around the hull creates a low pressure area beneath the ship, causing it to squat. This can lead to a reduction in UKC, which is the distance between the ship's keel and the seabed. Squat can be influenced by factors such as the ship's speed, shape and the displacement, as well as the depth of the water. Pilots and ship's captains need to be aware of the squat and navigating in restricted or shallow water to ensure safe passage. Squats may be calculated CB. Okay. Now, what is shallow water? Shallow water, and what are the effects of shallow water? Effects on the turning ability. And the ship is turning the shallow water, the tactical diameter increases. Okay, increase in turn moment of the resistance. Okay, effect on the ship speed. When ship moves into the shallow water, ship speed is reduced due to the increased wave making resistance and deterioration of propulsive efficiency. Effect on the ship speed. When the ship moves into shallow water, the ship speed is reduced due to the increased wave making resistance and a deterioration of propulsive efficiency. What is an abort point? It is the last point when you can abort the passage. So, making the abort point shall be such as be able to turn vessel safely. Any emergency unforced changes to the plane are included in the abort point. It is the last point when you can abort the passage. So, the making the abort point shall be such as able to turn the vessel safely. Any emergency unforced changes to the plan are included in the abort point. Once the abort point is crossed, vessel is fully committed to the passage and must continue. Abort point of no return, it is the point where you committed and cannot abort the passage. Point of no return is not related to the width of the channel or turning of the vessel. With the point of no return, there may be sufficient sea room to the vessel, but the vessel cannot return to where it came from because the condition have now changed. One example of point of no return is while proceeding in a river with falling tide. If the next point is changed or cancelled after the passing the point of no return, then vessel cannot return back because the tide now will be less than it was a few hours earlier when the vessels passed the same location. Crash stop is usually the term used when the ship has to sudden stop in emergency situation. Here the engine, which is moving in the an ahead direction, is given an order to full astern, leaving the rudder in the midship position to stop the ship within the minimum speed distance shortest possible time. The stopping distance data and chart is given in the sea trials for the ship and okay. What is the smelling the ground? Smelling the ground is what is smelling the ground? This occurs when a ship is nearing an extremely shallow depth of the water, such as the shoal. The ship is likely to take a sudden shear. Causes or deviating from its sudden shear. The ship is at a risk of sudden veering off, changing its course of direction from the intended course or deviating from its intended. The shear is first toward the shallow, then violently away from. In narrow channel, in narrow passage or canal, it can produce a dangerous shear towards the opposite shore or bank, but it can be beneficial if the water opposite of the shoal is deep and safe. Now, procedure for Williamson turn. Rudder hard over, okay, now hard over casualty after deviation from original course by 60 degrees. Rudder hard over to the opposite side when heading 20 degrees short of the opposite. Rudder to the midship and ship will be turned. Now what is Williamson turn? You put the wheel hard over to the side, okay, 20 degrees for person, okay, ठीक है. Now what is Anderson turn? Must be, it is the fastest recovery, good for ships with tight turning abilities, okay. Anderson turn. Rudder hard over in immediate action situations only. Casualty. Original course 250 degree. Rudder to the midship. Opposition stopping maneuver to be initiated. Okay. Now describe Schorner effect. It will be vessel back in the wake. Less distance is covered, saving time. Procedure for Schorner not to be used in immediate action situation. Rudder hard over after deviation from the course original by 250 degree. Rudder hard over to the opposite side when heading 20 degree short of the opposite to the midship, so that vessel will turn to the opposite, okay. Now Laurent turn must be used when used in heavy weather, facilitate launch and recovery of rescue boat, facilitate rescue work by other craft. Circling calms the sea by disturbing wave patterns. Additional ship circling windward will calm the seas further. Procedure for Laurent turn. Heading into the wind at full speed, beginning the circle, reduce to the slow when wind is abeam. When wind crosses, turn to pass opposite quarter, increase to half speed, continue circling as calm water is needed. Now slow down to the stop and launch recovery rescue boat on leeward side inside the circle. Now what is a wheelhouse poster? The wheelhouse poster is a large document poster in a conspicuous area on the bridge. It contains the general particulars of the ship, engine characteristic and stopping distance, and in laden a ballast condition. It will also provide illustration of ship's movement, including steering particulars, turning circle, as well as emergency maneuvers. The performance of the ship may differ due to the environmental, hull and condition. The IMO has developed a number of regulations and guidelines directly regulates the number of the wheelhouse poster and pilot card. However, the International Safety Management Code or International Safety outline the requirement for a safety management system on board ship. The topmost information for the wheelhouse poster would be the particular of the ship. This includes the ship's name, call sign, gross tonnage and the net tonnage. The next part of the poster will be draft of the vessel, steering particulars and the anchor chain data. Drafts can either be a loaded ballast condition or departure drafts and arrival draft. Another important part of the poster is the information or anchor chains. Another important part of the departure draft and the arrival draft. Another important part of the poster is the information on another chain. This part informs the ship's crew and pilots how many anchors this vessel currently has, including the spare. Anchor important part of the poster is the information or anchor chain. The ship's crew and pilots how many anchors this vessel currently has, including the spare. The wheelhouse poster also include the propulsion particulars of the vessel. The type of engine and type of propeller is indicated. It will be a corresponding RPM to each. This gives the corresponding RPM to each specific speed of the engine, from full speed to the its speed ahead, both in ahead and astern propulsion. In addition, critical RPM is highlighted to inform bridge officers and pilots during channeling and berthing unberthing operation. The actual speed of the vessel in knot is also displayed for ballast and loaded condition. What factors are calculating under clearance? Factors affecting UKC: draft of the ship, tidal variations, squat effect, seabed conditions, nature of the seabed, whether it's soft or hard, can affect the ship's ability to maintain sufficient UKC. Soft sediment may cause the ships to settle deeper. Navigational errors, inaccuracies in navigation charts or accuracy in the determining ship's positions can lead to a miscalculation in UKC. Environmental conditions, like another adverse weather conditions such as the strong condition, waves or storm surges, can affect the water level and consequently impact the ship's keel clearance. Ship's dynamic. The ship's response to rudder movement, propulsions, and other dynamic factors can influence its positions and draft. Dynamic stability. The dynamic stability of the ship in various conditions, including turns and maneuver, can affect the UKC. The dynamic stability of the ship in various conditions, including the turns and maneuver, can affect the UKC. Contingency. Unexpected events such as engine failure, steering malfunction, or other emergency may require additional keel clearance for the safety. Unexpected events such as engine failure, steering malfunction, or other may require additional keel clearance for the safety. Okay, what is a critical RPM? Critical RPM is provided in the wheelhouse poster. It is runs at the resonance with the surrounding structure, is called critical RPM, when machinery operates at or near its natural frequency and is in sync with the natural frequency of the surrounding structure. It can lead to a condition known as resonance. Resonance can result in amplified vibration, stresses, and oscillation, which may lead to the excessive wear and tear, structural damage, or even failure of the machinery or structure. Each structure has its own frequency of vibration. Example: a marine propulsion engine has such a natural frequency of vibration. The structure of which is to be installed vibrates at a certain natural frequency. If the natural frequency of the engine coincides with the structure, the entire assembly vibrates and its resonance with high amplitude. This can cause damage to its structure component. It is found at the RPM at around with this happens, it's around 40 RPM. It is found at the RPM at around which this happen is around 40 RPM. So the engines are never run at this RPM for continuous period. What is a stopping period and its IMO criteria? Stopping distance is which the track reach in the full astern stopping race should not be exceed 15 his length. What is the UKC policy of your last? The clearance of the the ship has a summer draft for at least 10 meters, should maintain the UKC of 10% of the draft at approaches to 0.3 meter when alongside. Ships having draft of 10 to 70 meters should have a maintained UKC of 10% draft approaches 0.6 meter when alongside. Ships having a draft 70 meter when 10%. Okay, whenever it declares maximum draft alongside, the ship does not exceed same and should arrive in even clean conditions. All precautions should be taken in tidal pose and ensure it remains okay. What are the factors affecting maneuverability of underwater hull geometry, pivot point, propeller, and rudder? What are the factors affecting maneuverability of the vessel? Now we are going with the IMSAR, the International Aeronautical and Maritime Search and Rescue. IMSAR manual is a manual for the organization and operation of maritime and aviation search and rescue. The IMSAR handbook is jointly published by two UN agencies, that is ICAO and IMO. It contains the guideline for search and rescue in terms of shipping aviation. The purpose of a COM is to ensure that a cooperation between the two areas of operation is effective, and that cooperation can be carried out in actual rescue operation between different organization rescue unit. It is important to ensure smooth cooperation between the two areas because many ships and aircraft accidents involve both ships and aircraft in the search and rescue operations. The IMSA manual consists of 3 volumes: Organization and Management, Mission Coordination, Mobile Facilities Carried on Ship, Volume 3. IMSA content is of overview, rendering assistance, on-screen coordination, onboard emergencies, regulations of the International Convention for Safety of Life at Sea, search action message, factors affecting observers, effectiveness, standard format for search and rescue, set reporting format, and search SAR briefing and debriefing form. Now, following terms may be understood in regard of this. What is the in such patterns? Datum. It will be necessary to establish the datum or geographic reference from the area to be searched. The following factors should be considered: reported positions and time of SAR incident, time interval between the and arrival of SAR facilities, estimated reported position, time of SAR incident. The following factors should be considered in necessary to be searched. The following time interval between the incident, estimated surface movement of the stressed craft or survivor depending on the leeway and total water current, drift and distance is multiplied by the time. Datum position is found by the moving from the inset position the last crowded datum. Track spacing, the distance between two adjacent track is now called the track spacing. Formula is for the multiplying the uncorrected track spacing multiplied by weather correction factor. Expanding squad search. More effective when the location of the search point is known within the relatively close limit. The common search point is always the datum positions, often appropriate for vessels or small boats to use when searching for persons in the water or other objects with little or no leeway. Due to the small area involved, this procedure must not be used for simultaneously by multiple aircraft at a similar altitudes or by multiple vessels. Accurate navigation is required. The first leg is usually oriented directly into the wind to minimize the navigational errors. It is difficult for fixed wing aircraft to fly legs close to datum if phi is less than 2 nautical miles. It is difficult for fixed wing aircraft to fly legs close to the datum if phi is less than 2 nautical miles. Now, sector search. Most effective when the positions of the sector when the position of the such object is accurately known and such area is small. Used to search a circular area centered on datum point. Most effective when the position of the such object is accurately known and such area is small. Used to search a circular area centered on a datum point. Due to a small area, this procedure must not be used by multiple aircraft or similar altitude. Aircraft may be used for perform independent. Okay. Basically, for aircraft, the search pattern radius is 5 to 20 nautical miles, and for vessels, it is 2 to 5 nautical miles, and each turn is of 120 degree. Normally used to turn to starboard. Normally turned to starboard. Track line search. Normally used when an aircraft or vessel has disappeared without a trace along a known route. Often used as an initial search effort due to the ease of planning and implementations. Consists of a rapid and reasonably thorough search along an intended route of the distressed craft. Search may be along one side of the track line and return in the opposite direction of the other side. Search may be along the intended track and once on each side. Then search facility continue on its way and does not return aircraft and frequently due to high speed. Okay. Parallel sweep search. Parallel sweep search to such a large area where when the survival location is uncertain. Most effective over water or flat terrain, usually used when large surface area must be divided into sub area for assignment to individual search facilities on screen at the time. The common search point is the one corner of the sub area, one half track space inside the rectangle from each of the two sides forming the corner. Such legs are parallel to each other and to the long side of the sub area. Such legs are parallel to each other and to the long sides of the sub area. Now, what is a coordinated aircraft vessel search pattern? Normally used only if there is an OSC present to give direction, on-screen coordinator present to give direction to the and provide communication with the participating aircraft. Creeping line search coordinate is often used. Creeping line search normally used only if there is an OSC on-scene coordinator present to give direction to and provide communication with the participating. Creeping line search coordinated. Okay. Creeping line or coordinated search is often used. The aircraft does most of the search while the ship steams along a course at a speed as directed by the on-screen coordinator so that the aircraft can use it as a navigational checkpoint. Now, the aircraft as it passes over the ship can easily make corrections to stay on the track of its search pattern, give a higher probability of detection than can be normally be attained by an aircraft searching alone. Now, contour search. This is used around the mountain in valleys as in highest point it goes from top to bottom. Such altitude which is 150 300. The aircraft may contain descending orbit. यार ये कौन पड़ेगा? Now, what is the SAR mission? They are the highest rank officers. They normally will have one or more person or agencies for whom this designation may be appropriate. One or more एक आदमी भी हो सकता है या तो पूरा एजेंसी भी हो सकती है. SC have the overall responsibility for establishing, staffing, equipping and managing the SAR system, establishing RCCs and rescue sub centers, providing or arranging for SAR facilities, developing SAR policies. SAR mission coordinator. Each SAR operation is carried out under the guidance of SMC. These functions exist only for the duration of ship's specific SAR incident and normally performed by RCC chief or a designee. The SMC have the assisting staff. So वापस बना the SAR coordinator staffing okay, providing or arranging SAR for developing SAR policies. Now, SAR mission coordinators. Each SAR operations is carried out under the guidance of an SMC. This function exists only for the duration of specific SAR incidents and is normally performed by RCC chief or a designee. The SMC may have assisting staff. The SMC guides a SAR operation until a rescue has been effected or it becomes apparent that the further effort will be of no avail. The SMC should be well trained in all SAR processes, be thoroughly familiar with the operation SAR plans and gather information about the distress situation, develop accurate and workable SAR actions plans, dispatch and coordinate the resources to carry out the SAR missions. SMC duties include obtain and evaluate all data on the emergencies, ascertain the type of emergency equipment carried by the missing or the SMC should be well trained or develop accurate and workable SAR actions plan, dispatch and coordinate the resources to carry out the SAR mission. SMC duties include obtain and evaluate all data on the emergency, ascertain the type of emergency equipment carried by missing or distressed aircraft, remain informed of the prevailing environmental conditions, if necessary, ascertain movements and location of vessels and alert shipping is likely, search area for rescue, lookout and for radio watch, plot the area to search and decides on method and facility to be used, develop the search action plan and rescue plan as appropriate, coordinate the coordinate the operation with adjacent RCCs when appropriate, arriving briefing and debriefing of SAR personnel, evaluate all reports and modify such plan as necessary, evaluate for refueling of aircraft and for prolonged search, make arrangement for the accommodations of SAR personnel, arrangement for delivery of supplies to sustain survivors, maintain in chronological order an accurate and up-to-date record, issue progress reports, recommend to the RCC chief the amending or suspending of the search, release SAR facility when assistance is no longer required. On-screen coordinator. When two or more SAR facilities are working together on the same mission, one person on screen may be needed to coordinate the activities of all participating facilities. The SMC designate and OSC, who may be person in charge of a search and rescue unit, ship or aircraft participating in a search or nearby facility in a position to handle OSC duties. The person in charge of the facility to arrive at the scene will normally assume the OSC function until the SMC arrange for that person to be relieved. Describe the vertical sextant angle in detail. It is the angle obtained by a vessel, by a lighthouse, or an object ashore. The sextant is held vertically. The top of the lighthouse is brought to the foot of the sextant and the angle is measured. The following are the uses of vertical sextant angle. To get the distance of a lighthouse, height of the lighthouse in meters, multiply by 1.854 divided by the vertical sextant angle in minutes. It is to be noted that the height of the lighthouse used in the height of the lighthouse are given the chart plus minimum minus the difference of the mean high water and the present level of water. The VCA used here is obtained by applying index error to the sextant angle obtained and then changing it into minutes. Describe the horizontal sextant angle in detail. It is one of the methods of fixing a vessel's position is by means of observing a horizontal angle is obtained by horizontal objects at the observer. When the horizontal angle obtained between two terrestrial objects is known, a circle of position can be obtained which is drawn to the chart. The intersection of this circle of position with another position circle or a position line will fix the position of the ship. Normally, three switchable objects are chosen from the chart and the angles at the observer contained between the two parts. Now we have to repeat it again. It is one of the method of fixing a vessel's positions by means of observing a horizontal angles obtained by a shore object at the observer. When the horizontal angles obtained by two terrestrial objects is known, a circle of positions can be obtained which is drawn on the chart. The intersection of the circle of positions with another position circle of the position will be fixed the position of the ship. Normally, three suitable objects are chosen from the chart and the angles at the observers contained between the two pairs with the left hand and the middle object and the right hand on the middle object are measured with the section. The two horizontal angle between the three objects give the two. Okay, ठीक है. What is a leading light? Quite often at the entrance of the approaches or to the harbor, two leading lights different characters are erected some distance apart in such a manner that a marina entering the harbor correctly and appropriately will see them in a line are called leading lights. The leading lights indicate to the navigator that the ship lies on a line joining the two lights can is thus entering the harbor or port correctly, clearly of dangers to navigations. Leading lights including a main light and a minor light of a lower elevation and to the seawards of the main light placed along a directions which helps to take the transit bearing advantage of a leading light. These leading lights indicate a safe passage of the vessel in a channel. The leading light helps in fixing the position of the ship. The leading light also helps the navigator in finding the compass error. The true transit bearing offered to leading lights is read of the chart and the compass bearing of the two lights when is transit is taken and the difference between the two bearing is the compass error. What are the types? Describe the types of type. There are semi-diurnal, diurnal, mixed and spring nip. Okay, semi-diurnal. What is semi-diurnal? Is the one in equal to the two low tides each. Two nearly equal to high tides and two low tides. That is Bay of Bengal. Diurnal in 24-hour period of time by single high tide and single low tide. This means that a location is it's a equal high tide, two equal. Okay, दो equal है तो दो है तो semi-diurnal. एंड अगर एक है तो डायनल. स्प्रिंग टाइड क्या होता है? डेट इज इन अ लाइन. Such tides called as spring tides. Spring tides are formed when the sun and the moon are in a line. Sun, moon are in a line. Sun, moon and earth in a line. And nip tide is the opposite in the right angle. Now what is standard port? Standard is for tidal which is prediction are directly given. Secondary ports are ports for which the tide rates have to be calculated because on the primary port. Okay. Now what is defined? Luminous range. Luminous range is for the distance it can seen And depending on the current atmospheric conditions, luminous range is the maximum range at which a vessel can see in any given meteorological visit. Nominal range is visibility of 10 mile is possible. The range that appears on chart and in list of flights. Geographical range is the maximum distance at which a light can be seen at a given time, determined by elevations of the vessels at a height, and the formula for geographical is 2.095 under it h plus 2.095 the height of the light and height of the observer. Rising or dipping a light, rising or dipping, the distance for sea horizon in nautical miles is 1.15 under height in feet, height in meter 2.0. Okay, the 2.095 we have to remember. If the distance beyond when a target of the given height will not be visible from the observer's position or height of eye owing to the intervening curvature of the earth, thus this range is dependent on height of eye, it is height of object only. The meteorological visibility, however, should be good enough for an object or a light to be visible at its geographical range. Meteorological visibility and luminance range. Okay, again, it is the distance beyond which a target of a given height will not be visible from the observer's position, height of eye, owing to the intervening curvature of the earth. Thus, this range is dependent on height of eye, it is height of object only. The meteorological visibility, however, should be good enough for an object or light to be visible with a geographical range. Meteorological visibility and luminance range of the light is not required to be known, and calculating the rising of the dipping distance, this may be known as the, again, rising or dipping of light is connected to the geographical range. It is the distance which a target or a given height will not be visible from a observer's position or height of eye. It is the distance beyond which the given height will not be visible from the observer's position. It is the distance beyond which a target or a height will not be visible from observer's position or height of eye, owing to the intervening curvature of the earth. The meteorological video should be enough for an object for a geographical, meteorological, luminance range of not 2.0 distance of a sea, height in meters. What is a tropical TRS? A tropical revolving storm is a small area of low pressure around which winds of a gale force, that is 34 knots and a force 8 or more, blow spirally inward anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. In case of violent tropic revolving storm, wind speed up to 130 knots have been experienced with occasional gusts up to 150 knots. Occasional gusts up to 150 knots. In case of violent tropical revolving storm, wind speeds up to 130 knots. And okay, structure of TRS. A well developed TRS has three distinct parts: the eye of the vortex, the eye wall, the outer storm area. The eye of the vortex, a calm central area where diameter 4 miles and 30 miles, the average being about 10 miles. The eye wall, an inner ring of hurricane force winds having a width usually between 4 miles and 30 miles. The winds in the eye wall blow in a perfectly circular path with a speed as high as 130 knots with occasional gusts up to 150 knots. The pressure gradient in the eye wall is very steep, and therefore the barograph will register a near vertical trend downward before the eye wall and the upward behind it, as shown in the accompanying figure. The outer storm area, the area surrounding the eye wall having a diameter between the 50 miles and 800 miles, the average being about 500 miles. Wind in this region are strong and the pressure gradient is much less than the eye wall. The area surrounding the eye wall having a diameter between 50 miles and 800 miles, the average being about 500 miles. Winds in the region are strong and the pressure gradient is much less than in the eye wall. Now, behavior of wind in TRS. Wind direction. If a stationary observer in right hand semicircle will veer if he is in left hand, it will steadily. This could look for okay. Direct part of the wind direction will remain fairly steady. Wind direction, if the stationary observer in the right hand semicircle, the wind will veer steadily, and he is in the left hand, so it will back steadily. This all good for north and south. If it is in direct part of the storm, the wind direction will remain fairly. Angle of indraft. Now this is something wind force. The wind force will increase as the atmospheric pressure falls, and angle of indraft 45 and gradually decrease until it's zero, and the other one. We have to directly read this. How we will be facing it, that is more important, na? Warning sign of wind. This is the most repeated questions. So what is it is all about? The very violent winds or the eye walls and swell out in a radius direction. Swell can be experienced as much as 1,000 miles away. And the speed of travel swell through approach from the direction of storm center. Okay. Atmospheric pressure. The approach for this should be suspected if the ship is in an area where TRS generally occur, if the time of the year is within the season when TRS generally occur, the downward variant pressure is 3 millibar below normal. Okay, if the changes is there is a variation of 3 millibar below the present of TRS is confirmed, the foregoing conditions are met, and the fall of benefit is more than 5 degree below normal. Note, a pressure drop of 20 is sufficient to cause a well developed TRS. Okay. Storm warning. Weather reports based on satellite pictures and observation from other vessels may contain storm warning, which give the position pressure of the storm center and also probable directions of movement of storm. Cirrus clouds in bands or filaments aligned towards the direction of the storm center. Unusually clear visibility may occur. Sometimes peculiar dark red copper color of sky is seen at sunset before a TRS. Cirrus clouds in the bands or filaments aligned toward the direction of the storm center. Cirrus clouds in bands or filament aligned towards the direction of the storm center. Unusually clearly visibility may occur. Unusually clear visibility may occur. Sometimes a peculiar dark red copper color of sky is seen at sunset before a TRS. Increase of wind force as the pressure falls. Threatening appearance of dense heavy clouds on the horizon. Frequent tightening may be seen. Defined with respect to TRS track, the route over which the storm center has already passed. Path predicted. Trough, the line drawn through the center of the storm at right angle to the track. Okay, ahead of the trough, pressure falls, whereas behind it pressure rises. Vertex of chord, ahead of where pressure drop and behind the rise. Okay, the westernmost longitude reached by the vertex of chord. The westernmost longitude reached by the storm center when recurving takes place. The trough, the line drawn across the center of the storm at right angle to the track. The line drawn through the center of the storm at right angle to the track. The line drawn through the center of the storm at right angle to the track. Okay, trough, basically a line drawn at the center of the storm at right angle to the track. Vertex of the chord, the westernmost longitude reached by the storm. The westernmost longitude reached by the storm center when recurving take place. Recurving take place, right hand semicircle, that half of the storm center that lies to the right hand of the observer who faces along the path of the storm. Left hand semicircle is the north hemisphere. Is okay. The half of the semi lies to the left. The half of the storm center that lies on the left of the observer who faces storm. Okay, left. Okay. Dangerous semicircle, right hand semicircle is in the north and left hand semicircle in the south. Right hand semicircle is the dangerous vice versa. What are the avoiding action we will approach in? Okay, avoiding action. Now what we will be doing as a sailor to save our ship? Obtaining the bearing of the storm center, face the wind, and according to Ballot's law, the storm center will lie 8 to 12 points on your right in the northern hemisphere and left in the southern hemisphere. Considering only northern hemisphere, face the wind and approach to by ballot slot. The storm center will be 8 to 10, 12 points on your right. In the northern hemisphere, if the pressure has fallen way below normal, allow 12 points on, as it means that either the vessel is in the outer fringes of the well of a well developed TRS, or that a new TRS is forming in the vicinity. If the pressure is fallen to any below, allow 8 point, as it means that the vessel is near the eye wall of a developed TRS. 5 below 12 points, as it means that the TRS is in the outer fringes of, and 12 allowed 12 on your right in the northern hemisphere. The storm center will lie 8 to 12 points on your right in the northern hemisphere, according to facing to 12 point on the northern hemisphere. 8 to 12 point in the northern hemisphere, allow 12 points, as it meets it's fallen 12 points, and if the another 12 point, then allow 8 points. Means okay, ascertain in the way the semicircle of the vessel lies in the right. For stationary, observe the wind veers clockwise. Okay, wind observation through log debris during bad weather should be compared with the 2 hours earlier. This is to give the time for significant veering or backing, and hence weed out errors that may caused by the irregular gusts of wind. Veering or backing one detected should be continuous while the observer remains stationary. That is, a veering wind should continue to veer and a backing wind should continue to back. If the wind veers at first and then backs, or if it is backs at first and then veers, the vessel must have passed from one semicircle into another due to the change of path of the storm. Veering once detected should be continuous while the observer remains stationary. That is, a veering wind should continue to veer and a backing wind should continue to back. If the wind veers at first then the backs, or if it is back at first and then veers, the vessel must have passed from one semicircle into another due to the change of path of the storm. Take avoiding action. Any avoiding action should aim to keep the vessel well out of the storm center. If the vessel is in the port when a storm warning is received, it may advisable to proceed well out to sea so that the vessel will have plenty of sea room and sufficient depth of water to prevent the vessel from pounding on seabed during the pitching and heaving. Seabed during pitching and heaving. Okay, vessel pounding. Okay, if any action to keep the vessel well clear, if a vessel is in the port with storm, a warning is received, proceed well out of the sea till the seabed during pitching and heaving. Okay, if proceeding out of the sea is not, it will be advisable for vessel to anchor outside the port in whatever shelter she can find. Drop both the anchors with several shackles of cable out on each. The engine should be readily burst of engine movements may be necessary to prevent the dragging of the anchors. Out in the open sea, the following action is recommended to keep the vessel out of eye. It is eye wall. Out in the open sea, the following action is recommended to keep the vessel out of eye. If the vessel is in the dangerous quadrant, the proceed as fast as practicable with the wind to 1 to 4 points on the starboard bow. When the vessel in the dangerous quadrant, proceed at first as practicably with the wind on 1 to 4 point. If you are in dangerous quadrant with the wind on 1 to 4 points on starboard bow in the southern hemisphere, 1 point for slow vessels less than 12 knots and 4 point for fast vessel more than 12 knots. 1 point for slow vessel, keep your vessel the wind on the starboard bow. 1 point for vessel with slow speed and 4 point for fast vessel 12 knots. Altering course so as the wind veers back in the southern hemisphere. As the wind veers back, this action should be kept. Altering course as the wind veers back in southern, this action should be kept up until the pressure rises back to normal and until the vessel is outside the storm area. If vessel is in the navigable semi, proceed as safe speed as practicable with the wind about 4 points on the starboard quarter and the port bow. This is in the 1 point on the port bow. Okay, port bow. And here, if you are in the so if you are in the past navigable semicircle, port quarter, port bow, port quarter. Okay, proceed as with the wind speed of the port quarter, altering course and the wind backs where this action will be kept up until the vessel rises back to the normal, until the vessel is outside the storm area. By Ballard's law, face the true wind with the low pressure area where will be on your right in the northern hemisphere, left in the southern hemisphere. Face the true wind and the low pressure area will be on your right in the northern hemisphere, left in the southern hemisphere. Face the true wind, the low pressure will be on your right in the northern. Okay, caution while applying near the equator. Okay, temperature inversion. In troposphere, the temperature of air normally falls steadily as the height increases. Sometimes local influences causes the temperature of air to increase with the height instead of falling. This is called a temperature inversion. In troposphere, the temperature of air normally falls steadily as height increases. Sometimes local influences cause the temperature of air to increase with the height increase instead of falling. This is called a temperature inversion. This is called as a temperature inversion. What is a temperature inversion? In troposphere, the temperature of air normally fall steadily as the height increases. In troposphere, the temperature of air falls as the height increases. Sometimes local influences causes the temperature of air to increases with the height instead of falling. Local influence causes the temperature of air to increase with instead of height. Increase with the height instead of falling. This is called as a temperature inversion. What is the meteorological equipments are on board? Aneroid barometer, instrument for measuring the atmosphere, the hygrometer, obtaining the dew point, dry bulb temperature, Stevenson's scale, same the Walling cyclometer. What are the correcting applied to the reading obtained from correction for the height 1 millibar? We all know that 1 millibar for 10 meters. See that? Okay. Now index error, if index is not given, the correct slit of correction will be applied for height, latitude and temperature. The difference between the collected barometric pressure and the actual barometric pressure calculated in the index error of the positive if the former is less and negative if the former is more. That is, if corrected barometric pressure is 0.8 and the actual barometric pressure is 1005.2, the index error is minus 0.0. Okay, if the corrected is and the actual is 0.4, then okay, will be negative. The actual is okay. If the corrected one is the actual atmospheric pressure is okay, this will be minus. Okay. Okay, barometric tendency. Barometric is the difference between the atmospheric pressure at the time of observation and the atmospheric pressure 3 hours earlier. It is expressed in millibar and up to 1 decimal of a millibar. Barometric tendency is the difference between the atmospheric pressure at the time of observation and the atmospheric pressure 3 hours earlier. It is expressed in millibars and up to 1 decimal of a millibar. Barometric tendency is the difference. Barometric tendency is the difference between the atmospheric pressure at the time of observation and the atmospheric 3 hours. Oh God. Barometric tendency is the difference between the atmospheric pressure at the time of observation and the atmospheric pressure 3 hours earlier. It is expressed in millibars and up to the decimal of a millibar. Barometer is the difference between the atmospheric pressure at the time of observation and the time of pressure 3 hours earlier. This gives the forecast a good idea of the rate of change of pressure, which is useful for predict the movement of the pressure systems. Isobaric, it is for easy comparison of forecast that the barograph and the barometer reading in accordance with the UTC GMD. Okay, ठीक है. Now what is T? ये तो पूछा नहीं है कभी. What is true wind and apparent will you find out? The true wind is the actual wind that is blowing in the direction of wind blowing the observer, the line of waves, the direction of true wind. Okay, apparent wind, the direction and the force of wind experienced on a moving ship is the apparent wind. This is the resultant of the true wind and ship's reversed movement. The shipboard anemometer measures the speed of the apparent wind. What is the relative wind, humidity, and a dew point? How do you obtain? Relative humidity is the percentage of the ratio of the actual water vapor contained in a given sample of air to the maximum quantity of water vapor that the sample can hold at that temperature. Relative humidity is the percentage ratio of the actual water vapor contained in a given sample of air to the maximum quantity of water vapor that the sample can hold at that temperature. Relative humidity is the percentage ratio of the actual water vapor contained in a given sample of air to the maximum quantity of water vapor in that the sample can hold at that temperature. Dew point. If a sample of air was progressively cooled, its relative humidity will steadily increase. That is, the air will become relatively moister. Air will become relatively moister at some temperature. The air will become wet. That is, its relative humidity will become 100%. The air is then said to be saturated, and temperature at which this occurs is called the dew point temperature of that sample of air. Both relative humidity and dew point of air are found to be used as a hygrometer or psychrometer, and then consulting meteorological table, dry bulb treaters, and we get the relative humidity of the dew point. Okay, application of dew point: atmospheric sweat, this cargo sweat and all. Fohn wind effect is the phenomena where the leeward side of a mountain is drier than the warmer in the windward side and warmer than the windward side. The Fohn wind is the phenomena where the leeward side of the mountain is drier and the warmer than the windward side. This will be more pronounced if the wind was blowing from the sea toward a coastal mountain as the than the most. Okay. What is weather prognosis chart? Okay. These charts give the weather situation at preceding synoptic hour over the entire area. They show the weather experience at each land and ship station, pressure all pressure systems, isobars, wind direction, fronts, frontal depression, etc. predicted for specific future time. They may be made 12 hours, 1 day, 3 days before the specified, so that the shipmaster will route his vessels. A copy of the prognosis chart is compiled by a professional meteorologist after studying the weather readiness chart, upper air readiness chart, and take into account various other factors also. Now, what is autopilot? Autopilot is the basically used where ships has to steer. Yeah, shit. Now we are at the bridge equipments. Okay. Working of AIS. Ship's log, compressor amplitude method, hailing error corrector, quadrantal corrector, flinter parts. It's phasing and ranging. Segment of GPS. So let's go. इसमें यहाँ से HDAP ranging tracking LRIT, इसका LRIT communication service provider. Okay. So, should I read it from different notes or same? Thinking of reading from other notes. So, let's see we'll read it from here as well. So, what is autopilot? Sorry. Autopilot is basically used when ship has to steer a set course for a long course without alteration between and deviation from set course is controlled electronically and automatically. This will not only relieve the helmsman from steering duties but is also more efficient because as soon as the ship deviates from the set course, corrective action is taken immediately during the requisite amount of helm to bring the ships back to the set course. This is achieved by comparing the set course to steer as set by the navigator with the ship's heading obtained from gyro or magnetic compass. Any difference between the two will cause an error and corrective helm is applied to the rudder such that the heading is brought to the same value as the set course. Controls of the autopilot. In order to maintain a ship's course as accurately as possible, the helm must be provided with data regarding the ship's movement relative to the course to steer line. It is achieved by electronic circuits with the help of following controls which forms the heart of the control unit. Proportional control. The effect on steering when only proportional control is applied to move by an amount proportional to the off course error. The effect on steering when only proportional control is applied cause the rudder to move by an amount proportional to the off course error from the course to steer, and the ship will oscillate in either side of the required course. When the ship has gone off course to port from course to steer as shown in the diagram, an error occur and the helm has to be used to alter the course to starboard so as to bring the ships back onto the set course. As the ship starts to return to the set course, the helm is gradually reduced, and finally when the ship is back on the set course, the helm is removed. This rudder will be amidship as the ship approaches, as this causes an overshoot result in ship to go more starboard than required course. Correcting data is now applied, causing a port turn to bring the ships back to its original coastline. Derivative control में क्या होता है, its run start running parallel to rest soon as the external forces which was acting is removed, so it is start reducing going to the parallel. In derivative control, the rudder is shifted by an amount proportional to the rate of change of ship's deviation from the course. That is off course error. This is ship's deviation from the course to port causing corrective starboard to apply. The rate of change of course decreases with the result that automatic rudder control decreases at the point A. Rudder will return to midship position. The ship will now make a good course which is parallel to O with the continue to do so. Integral control. There is a certain errors due to design parameter of ships like shape of the hull, bow, going to port when ship is making a headway due to the transverse thrust, etc., which will have to be corrected. Data signals are produced by continuously sensing the heading error over a period of time and applying an appropriate degree of permanent helm is used for this purpose. The rudder used to correct the course will now about be this permanent helm instead of the actual midship. Permanent helm now act as a midship. पता नहीं क्या था यार. This is very confusing actually. What are the control providers on rudder control, outer rudder control, yaw, the rudder control to determine the amount of rudder to be used to correct the slightest amount of deviation from the set course. Counter rudder, this control determines the amount of counter action may be the rudder to be used to steady the ship on the set course, keeping the overshoot to a minimum. Too low a setting will allow the ship to overshoot and too high a setting will bring the ship back to the set course. What is the yaw? Yaw is the rotation of ship around its vertical axis which is typically aligned with the mast. The settling of the yaw controls depends on the wind and the weather condition and their effect on the course keeping ability of the ships. It is in bad weather with the wind rough sea, a higher value should be selected, while in calm weather, a low value is preferred. Your control on an autopilot is essential for the maintaining a vessel's course and stability by